All right, so here's our three-edge elastic problem. So it says the entrance of the Louvre Museum in Paris, France is a square pyramid with a height of 21.64 meters. What is the approximate volume of the Louvre pyramid round to the nearest cubic meter? So I've actually had the opportunity to go inside the Louvre. It is a famous art museum in Paris. If you have the opportunity, would not pass it up. So anywho, we need to find the volume of this square pyramid. So our volume formula for any pyramid is 1/3 the area of the base times the height. Now, this is a square pyramid. So again, to find the area of a square, which is our base, is base times height, or you can do side length squared. So notice that this capital B gets replaced with side length squared. Now, um, you know, you might miss this, so I'm pointing it out to you. So they give you the length of the side on the picture. So they should have put it in the problem too. So the side length is 35.4 meters and the height is 21.64 meters. So we're going to do 1/3 times 35.4 squared, because that's the side length, times 21.64. And this will give us our approximate volume. We're going to round to the nearest cubic meter. So when I go to here, so it was 1/3 times 30, I think it was 35.4 squared times 21.64. And there we go, 9039.4. This 0.4 does not affect the 9, so our answer is going to be 9039. So 9,039 and whatever the units are cubed. So 9039, and the units are meters, so we'll find meters cubed. And again, don't be concerned. You have to go all the way to the bottom where the cubic units are. Okay, next one. So it says the covering on a TP rests on poles that come together like concurrent lines. The resulting structure approximates a cone. If the TP pictured is 12 feet high with a base diameter of 14 feet, what is the approximate volume round to the nearest cubic foot? So again, we have a cone here, which is again a pyramid. So our volume formula is 1/3 the area of the base times the height. The base is a circle, so that's 1/3 pi r squared times the height. So we need the radius. Well, they give us the diameter. The diameter is 14. The radius is half of that, so your radius is 7. So 1/3 pi times 7 squared, and then your height is 12 times 12. We'll go ahead and type that into the graphing calculator and see what we get. 1/3 times pi times 7 squared times 12. I think it said round to the nearest cubic foot, so that means no decimals. So again, on here, the 7 does round the 5 up to a 6. 616, and that'll be cubic units. Six one six, and your units are feet, so cubic feet. And again, scroll all the way down to find the cubic units. Okay, 2 done, 1 more to go. All right, so this is one of those solids of revolutions problems. So it says, suppose you revolve the plane region completely about the y-axis to sweep out a solid of revolution. So automatically, you should know that if you start with a triangle and you revolve this, you're going to get a cone. Okay, so describe the solid, you're going to put cone. Right, and now let's go ahead and draw the cone. So again, remember, this just gets mirrored over here. And this bottom is going to be a circular base. And there's your cone. Okay, so to find the volume of the cone, you need to use the formula 1/3 area of the base times the height. Of course, the base is a circle, 1/3 pi r squared h. And now my dimensions, right? What is my radius? Well, the radius is going to be halfway across this circle. That radius is 4. The height is going to be from the very top vertex down to your base. That's going to be a height of 3. And there's your dimensions. 1/3 pi times 4 squared times 3. You can use a calculator. Do not type in the pi, though, when you use your calculator. 1/3 and 3 will actually cancel, and 4 squared is 16. So that's the answer, whether you use a calculator or not. 16 pi. Notice when I type it in, 16, the pi symbol is right there. All right, so a couple extra volume problems. Good luck with your homework.